important anyway. Sorry we missed the first 6 slides. Okay, so the urinary system is a pretty simple system in terms of the number of organs involved. It's simply 2 kidneys down in your back of your belly. They are retroperitoneal. Remember, they live behind the peritoneal cavity. There's two kidneys, and then each kidney has a tube coming out of it called a ureter that carries the urine down to your bladder. And then you've got a bladder down here, and then the bladder connects to the outside through a tube called the urethra. The urethra is a really simple and very short tube in a woman, probably about 1 inch long, from the neck of the bladder to the outside. In a male, it can be, 14 inches long, guys? Just kidding. It's usually about 4. But anyway, it goes all the way out through the penis. The difference in the male and female, and we'll discuss this, is that the urethra only has one function in females, and that's to carry urine. Whereas in the male, it not only carries urine, but it carries semen, carries the reproductive system as well. So there are some differences there. We'll talk about it. What are the functions of the urinary system? These are pretty straightforward, but yet pretty important. One is that our kidneys regulate our blood volume and our blood pressure. In other words, our kidneys decide if we have enough blood in us or if we have enough blood volume in us. And if we have too much, then the kidney senses that and the kidney starts making more urine and to bring it down. And if we don't have enough, then the kidney will hold on to our water and hold on to our salt and increase our amount of volume. For example, if we had been bleeding and lost some blood, we would be making very little urine. So not only does it adjust the amount of water lost, but it also releases erythropoietin and renin. These are 2 hormones that we'll learn a lot about. Erythropoietin, I think we've already talked about it, known by the initials EPO. It's the major performance-enhancing drug used by the long-distance runners and the bicyclists that need lots of hemoglobin, lots of blood to carry lots of oxygen so they can exercise and do the crazy things they do for 8 or 10 hours a day. So we'll learn about erythropoietin. Renin is another hormone that controls the volume and the salt levels. It regulates our plasma ion concentration. We've already talked about a number of these before, and we're going to touch on them again. Calcium levels. Remember our calcium levels we have osteoblasts, which make more bone, so they suck calcium out of our bloodstream and turn it into bone, make more bone. We have osteoclasts. Remember those ones that have multinuclei and eat up bone? So if our calcium level is too low, the osteoclasts eat up the bone, and that releases the calcium into the bloodstream and makes our calcium level go up. Our sodium, potassium, and chloride, that's basically salt water, right? Sodium chloride and then potassium chloride are controlled in our kidney, and we have lots of controls on that we will talk about. In addition to deciding how much salt to let go, the body decides on how much acid to let go. So we control our pH through our urine. Now that's not the only way we control our our pH. What's the main way we control our pH? Breathing, right. So if we hyperventilate, what happens to our pH? We blow off our PCO2 and our pH goes up, right? We become alkali. And if we're not breathing enough and we're in cardiac arrest or something, for example, and we're not breathing, having an arrest, then what happens to our PCO2. It builds up very quickly. We become hypercapnic, and we become very acidotic very quickly. So when you get called to that code, one of the first drugs you're probably going to be giving is soda bicarb, which is pure bicarbonate, in order to try to bring the patient's pH up from the acid levels to get them normal, to try to get their heart going and so forth. So pH is very much regulated by our kidney. Now, whereas our breathing, we can change our pH in about a minute and a half by either breathing too much or not breathing enough. Our kidney is just as important, but it's a much slower thing. So our kidney kind of fine-tunes our pH. We conserve valuable nutrients. We've got to get rid of all these waste products that our body creates. We talked about urea the other day. The breakdown product of ammonium gets turned into urea. Urea is water soluble, so we can pee urea out. And that's one of the things we've got to get rid of. There's other things we don't want to get rid of. We don't want to pee out sugar, for example. But if our blood sugar levels are too high, if we were diabetic, for example, then we might be peeing out sugar, and that's probably not good, although it might be a great way to go on a diet and lose weight. If you're losing a lot of sugar, it's not a healthy thing. So, I think this line here can be, explained further by simply saying that our kidney decides what we want to lose and what we don't want to lose. We clearly don't want to lose proteins. We clearly don't want to lose sugar. But there's other things we definitely want to get rid of. And that's part of step number 5 down here, detoxifying poisons. Most poisons, we pee them out. We excrete them through our kidneys. And although the liver tends to break a lot of things down to get rid of them, if they're poisonous and we don't want them in our body, certainly the kidney does a lot of that too. Kidneys are located on either side of the vertebral column. The left kidney is a little bit higher than the right. Why do you think? Because there's this big organ over here on the right side which pushes it down, and it's called the liver. Yeah. On top of each kidney is an adrenal gland. We used to call them adrenal glands because they made adrenaline. We call them suprarenal glands, which just means above the renal on both sides. They do a lot of things for us besides make adrenaline. They just sort of, there's no real ligaments or anything that hold them there. It's just all the tissues around them kind of hold them in place. The kidney is protected very much because of where it lives way back deep down inside of you, which is a good thing, because if the kidney was laying right out front, you could ever get punched. Most of the time you'd probably bleed to death from it, but because it's way back in the back, hidden back there along either side of the vertebral column, way back in here, and the rib cage is protecting a lot of it in behind. They're in a pretty protected position. We'll look at the kidney under the microscope. It's got a fibrous capsule on the outside, which covers the whole thing. There's a little perinephric fat capsule that's around it. Perinephric just means around the kidney, nephric kidney. And then there's some fascia back there, which once again isn't really, it's not an anatomic deal, but it helps hold it into place. Here's what they look like from the back. The one on this side here, this is the left kidney. You see it's a little bit higher than the one on the right, but that's totally insignificant, really. Here's the 2 floating ribs. You remember the floating ribs, 11 and 12, don't attach to anything. You can, in fact, I was doing this with the 231 class this morning, having them lean over and try to feel the tips of their 2 floating ribs down there at the bottom. Obviously, the 2 biggest blood vessels in your body run right between the kidneys, the aorta right here, and the vena cava carrying blood back to the heart. The renal arteries are huge, and they bleed like crazy if they ever get torn. Indeed, our kidneys get about 20 to 25% of our total body's blood flow goes through our kidneys. Here's a cross-sectional view, like you'd see with a CAT scan more than likely. This is the left side because here's the spleen, here's the stomach, here's the lesser omentum, remember that. Here's the kidney back here, a renal artery going in, renal vein coming out, and the ureter is below this picture. Nice picture here. If you remember back to 232, we have 3 arteries that come off of the aorta that are unpaired, come off in the middle. The first one right here is called the celiac trunk, and remember it supplies the stomach and the spleen and the liver and mostly that's what it is, those 3 big organs from the celiac trunk right there. The next one is called the superior mesenteric artery, and it supplies virtually the whole small intestine. That was the one I talked about the other day, twisting in Jack Newman and causing the death of most of his bowel. The third one down here is the inferior mesenteric, which I guess they didn't even label on this diagram. There it is right there. And it goes to the left side of the colon and the sigmoid colon and the upper parts of the rectum. So that's the 3 unpaired arteries. Notice, of course, that the renal arteries are paired. There's also some lumbar arteries that come off kind of at every level along in there. And then these are important right here. These guys, which are illustrated here and here, I'll bet on this picture they're called the gonadal arteries. Here they are right here, the gonadal artery and vein. Now the important point for you to remember is that the gonadal arteries, obviously in the male, they go to the testicle to supply blood to the testicle. In the female, the gonadal arteries are called the ovarian arteries because they go to the ovaries. Those are the female gonads. But notice that despite the fact that the ovaries live at about this level down here in the pelvis, and of course the testicles then live about down here off the page, they come off way up high. They come off just a little bit below the kidneys up here, like in both sexes. And the reason for that is that early in our development, when we're a little bitty fetus and our body hasn't even decided whether we're going to end up being a boy or a girl, the ovaries and the gonads form up there. And then as we mature a little bit and the decision is made due to some hormones, whether we're going to turn into a boy or whether we're going to turn into a girl, then they migrate on down. If they're testicles, they migrate all the way down into the scrotum. If they're ovaries, they migrate all the way down into the pelvis where they hang at the end of the oviducts by the uterus. So always be aware of that, and we will see these in our cat. You'll see the gonadal vessels. You should pay attention to them. Here's the ureters, the tubes. The ureter tubes are pretty small, and they're not very exciting to look at. And one of the problems that we had at surgery was seeing them and telling what they were, because you didn't want to cut one of them. That would be a bad move. But what you could do was, with a pair of tweezers, you could tweak it. And every time you tweaked it, it would peristalse. And so you tweak it, and then you watch a peristalsis go down the ureter. Tweak it again, and watch another peristalsis. And that was the way we would identify those little tubes as ureters. The fact is that the kidney is making urine all the time, and the ureters, therefore, are peristalsing sort of all the time to carry the urine down. The bladder starts out really small, it fills up really big, and when it gets full, then obviously it empties itself. The hilum of the kidney is the main entrance, the side entrance to the kidney, where both the renal artery, the renal nerves, the renal vein, and the ureter. So these two are going in. The renal artery is carrying blood into the kidney. Renal nerves are carrying some nerves into the kidney. The renal vein is carrying the blood out of the kidney, and the ureter, of course, is bringing the urine out of the kidney that the kidney made. This is a cross section of the kidney. We will give you kidneys that are have been injected, red for arteries, blue for veins, and then you can cut your kidney in half. And when you do cut your kidney in half, you should get a picture that looks a lot like this. The artery and vein are not illustrated on this picture here, but you'll see them on the back side. This is the ureter coming out. These things here are the collecting ducts that collect the urine. The urine is actually made in these things called renal pyramids here, and the urine comes out through little holes right here at the tips of each one of these little papillae. So this is the renal medulla in here. Medulla is like, for lots of organs, we have a medulla, and then we have a cortex. The cortex is the outer layer. The cortex, as you can see, is this whitish area from and the outside out here. Just for a heads up, the cortex is where we're going to find all of the glomeruli, little gloms of arteries and veins. That is where the process of creating urine really starts. They're out here in this. And then they eventually work their way through some tubules, and they go down here into the renal medulla. They go down, they go up, and then they come back down a third time and empty out through these little papillae right here at the end of those pyramids. When you get your kidneys and you're dissecting them, I want you to notice the fact that you see this little fat right in here, and right there, and right there. That's really not even in the kidney. That's what's called the renal sinus, because if you just kind of stick your finger in on the front side of the collecting system here, or on the back side, you'll see that this fat, which is filling into empty areas in there, really isn't in the kidney itself. It's really just kind of around it. These areas that connect down there are called the renal columns. And I think I'll just leave it at that for now. Here's what the living thing looks like. It's the same exact picture. It's just not quite as obvious as that last one was. The key to making urine is following the filtrate as it flows through the nephrons. And remember what we called the unit of bone? In compact bone, we called it a osteon. Yeah. Well, this is a nephron. And a nephron is the unit of kidney. Basically, it's the part of a kidney that makes urine. So these nephrons are microscopic. You can see them under the microscope very easily. And they are tubes, a bunch of little tubes that start out in the cortex on the outside of the kidney, and that's where urine production begins. So basically what I'm going to be talking about for the next day or more is how that fluid passes through these different tubes as it passes through the kidney, how certain things are added to it, how certain things are removed from it, until we get the final product, which we call urine. Okay? I'll just leave it there. Blood supply to the kidneys, lots of blood goes to the kidneys, 1,200 cc's a minute. 1,200 cc's a minute, think about that. Somebody got a liter bottle of water around here. That's probably about a liter right there. You can imagine if that thing was being filled up every single minute with blood, that's a lot of blood flowing to the kidney. And it gets it through the renal artery, as I mentioned before. Well, what about sympathetic innervation? Remember that rest and digest stuff and that fight or flight? Well, obviously, sympathetic innervation, the fight or flight mode is very important in the kidney, because if you're in fight or flight mode, are you going to worry about making urine? No, you're gonna squeeze down the renal arteries that go to the kidney, and you're gonna sort of slow the blood flow and therefore you're going to slow down your urine output. In fact, you're probably not going to make hardly any urine when you're in sympathetic output. The best example to help you remember that is if you ever run a marathon. They have a whole lot of porta potties at the beginning of a marathon. That's because everybody's nervous, and they might only have 20 cc's of urine in their bladder, but they feel like it's full and they got to go pee before they start. But once you start running, you probably don't make any urine the rest of the race because you're sending all of your blood to your muscles and to your lungs to breathe with and so forth. And so that's why the sympathetic innervation is very important. Sympathetic innervation also causes the stimulation of this hormone called renin. Renin means kidney, obviously. And what it does is it stops the losses of water and salt. So you got to remember that we can make 3 liters of urine in an hour. If we have a whole bunch, if we're sitting here drinking water one right after another, we can make 3 liters or more of urine in a single hour. But we can also, if we're exercising and we don't want to be making urine, we can make 5 cc's of urine an hour because we don't want to lose that fluid. We want to save that fluid to pump through our blood vessels and also to sweat with when we're exercising heavily. Okay. This is something you're going to need to know. It's the blood flow to the kidneys. It's really not all that hard, but it does have a few names to it. So here's the renal artery coming in, and about the only branch off the renal artery is this little suprarenal artery that goes up here and then goes to the adrenal gland, which lives on top of the kidney. The adrenal gland actually gets 2 other blood supplies, but this is one you'll probably see. So then it comes on up here and it starts breaking up into 2 or 3 segments. So this is called a segmental artery, as illustrated right there. And then those segmental arteries come on up here, and they form these interlobar arteries. So they go between the lobes. This is a lobe, this is a lobe, and the interlobar arteries come up to here. And when they get to this line right here, which is really the line between the medulla, the medullary part of the kidney, which is the middle parts, and the cortex, which is the part out there, they split and go both ways. And when they do that, they're now called the arcuate arteries. And here it is, right here, arcuate arteries that arc around both directions. Coming off of the arcuate arteries are these ones that go straight out, and we call those the cortical radiate. In other words, they follow the radius. They're up in the cortex, so they're cortical radiate arteries. And these are the arteries that are actually going to send blood to the glomeruli, which is the first part of the nephron, which is the first place where urine starts to be made. Okay? It comes back through veins. They're all named the same thing. They're called arcuate veins and renal cortical veins, and then interlobar veins, and then segmental veins, and then the renal vein. Okay, easy enough. Renal vein enters into the, what does it dump into? Inferior vena cava. Thank you. Thought I was going to have to kill myself. Okay, meanwhile, back here, here's a little more close-up. Here's the segmental interlobar arteries right here, becoming the arcuate arteries and arcing around like this. And then please notice that those cortical radiate arteries, which go out this way, just simply go out towards the surface of the kidney. But as they do, they form a whole bunch of these little, they look like grapes on this diagram here. Each one of those is a glomerulus. Now, when I say that word glomerulus, I usually call it a glom. It's like a glom of little arteries, and they just kind of buzz and go all around and run around in circles in this little glom of arteries called the glomerulus, and that's where the first filtration is going to happen and where the first urine is going to be formed. There's just those arteries that we've already gone over. Okay. Now, I have tried to teach this a number of times, and I've tried very hard to make it very clear. And I finally found out that one of the things was if I just started at the beginning and went through it with the students, they kind of saw the trees, but they didn't see the forest. So then I started putting in a slide or two up front here to let you know where we're going to. Okay? So this is a picture that summarizes renal function. Okay? And you'll see this in your book. It's in there plenty of times. But let me just go over this, and I'm going to take 2 minutes here to kind of jump ahead and let you know kind of what we're going after. The blood comes up, and the blood comes up through these arteries that we've just been talking about, and it goes into this thing here called a glomerulus. It's illustrated right here. So that glom is a whole bunch of arteries that just kind of ball around and run around with each other, and then they go in there and they leave. And they have a little control valve going in and they have a little control valve going out. And think about it like this. If I had a pipe that was sending blood over here to the kidney, and I've got a pipe coming in and I've got a pipe coming out, okay? And if I could open the valve really open on this side, send a lot of blood in to those glomeruli, and then on the other side over here, coming out, I could tighten it down really tight, so it's very hard for that blood to get out. A lot of blood would be pushed out of the arteries because these arteries have kind of open sides. They're kind of like screen doors on the side. And so if the pressure coming in is high and the pressure going out is low, we push a lot of the blood out of the arteries and into this thing here, which is called the renal capsule, or the renal well, it's the cortex, but it's the proximal tubule, the renal tubule. So it pushes this water out into here, and it doesn't push the proteins out because the proteins can't get out through the little holes in the side of the artery, but it pushes a lot of water and salt out here into the tubule. And from this point forward, it's going to be a long process to actually purify it till it's really urine. The fluid in the tubule will come this way, and it'll go down through this tubule, which is called the proximal, goes through what's called the proximal convoluted tubule. Then it'll go through the descending limb of the tubule. Then it makes a loop down here, which is called the loop of Henle. Then it comes back up. It goes through the ascending loop, comes up here, does another little loop through the distal convoluted tubule, and then it comes back down here and heads out the final time down, and this is now called a collecting tubule. When the urine, this fluid, which we've been calling filtrate, gets all the way down to here, we now call it urine. And from there, it just goes out. It goes out through the ureter and out to be peed out. In the process, we've done a lot of stuff. And you'll see here's water coming out. Here's sodium and chloride being pumped out. Here's H2O being pumped out here. Here's sodium, more sodium. Here's different things being secreted, sugars being put back in, proteins are being put back in if they got out, and so forth. So there's a lot of things that happen as it flows down these tubules and flows through these different parts of these tubules before it actually becomes urine. Okay? We got to start somewhere. And so we're going to start and go through this system starting at the glomerulus. Okay? The basic processes involved in making urine are 3. The first one is called filtration. Filtration is pretty simple. Filtration is based on size only. So that it's kind of like, you guys ever make spaghetti and you've got a colander at your house and you take and the spaghetti's on the stove and it's been boiling, and then you take it and you dump it through the colander and all of the water just runs right out of it? right? And the spaghetti stays in the colander, right? Why does the spaghetti stay in the colander? Because it's big, okay? It's big, it can't fit through the holes. So think of the spaghetti as the proteins. So when our blood flows into that colander, so to speak, the only stuff that can get out is the water and the small things like salt, the chloride, and so forth. But the big things stay in the bloodstream, okay? So that's the first step. Everything starts with filtration, and you'll hear this word a lot. Then the next process involved in making urine is called reabsorption. And basically that means the body says, wait a minute, we don't want to lose all this water, let's reabsorb some of it. Oh, by the way, we don't want to lose all this salt, let's reabsorb some of it. We don't want to lose all this chlorine, let's pull those chloride ions back into the body, okay? So the second part of making urine is called reabsorption. And reabsorption is just what it says. It's bringing things out of the renal tubules, out of this stuff that's going to be urine eventually. It's pulling that back into the bloodstream, back into the body. Okay? Does that make sense? The third step is called secretion. Now, I think this is a confusing word here because it doesn't mean that we're going to secrete a bunch of urine or we're going to secrete a bunch of stuff. It means that it is secretion, but it's mostly things that we really want to get rid of that just didn't flow out. Either they were the wrong size to fit through the filtration thing, or we just want to get rid of them. And so we have processes in the kidney on downstream a little bit where secretion takes place. And this is where we actually pump things out back into the urine. We pump them because we want to get rid of them. If we want to get rid of them, we pump them into the urine, and then they're going to be out of our body, right? Okay. So we're going to talk about each of these in pretty much detail as we talk about how our kidney actually makes urine. Meanwhile, back to the nephron. The nephron is this long tube thing that goes up and down and all around that makes up the unit that makes urine. The renal corpuscle is the first part of it, and then the rest of it is the renal tubules. And I don't know why we put it in this order here on this slide, because strictly the renal corpuscle is where this all started. This is the glom of arteries, okay? So the renal corpuscle is a spherical structure. It's nice and round. When you look under the microscope, you will not have any trouble at all seeing the glomeruli. They're round. They look kind of like islets of Langerhans. They're so different from all the other tissues around them. And really what they are is just simply a bunch of blood vessels. So the glomerulus is these arteries. So you could draw it like this. You could say, okay, there's an artery coming in. And by the way, let's just call that the afferent artery. And that afferent artery comes in, and that artery winds around here in this glom of arteries, and then it goes out, and it goes out through another artery. And what should we call that other artery? Efferent artery, yeah, the efferent artery. So the exiting artery, efferent, is going out. The important point that you understand is that both of them are arteries. This is not an artery coming in and a vein coming out. They're both arteries. They're both under rather high pressure. And because of that, we can change the pressure here. There's muscles in the wall that change, that let more in or more out. And on the efferent artery, we have arteries that open up and let more out or let more in. And clearly, if you want to make the most urine, the way to make the most urine is to have your afferent arteries wide open and your efferent arteries closed down, because that's going to mean there's a lot of pressure in this thing, and that's going to push the water right out through the walls of these arteries in the glomerulus. Surrounding the glomerulus is this thing called the renal capsule, the renal corpuscle. So the glomerular capsule is this thing here that the urine, what's going to be urine, this fluid, this filtrate, gets pushed through into here. And from this point in, it's called filtrate as it goes on downstream and gets more completely purified into just what we want to get rid of and what we don't. We actually showed you renal glomeruli on the first day or second day of 231 because we showed you Bowman's capsule, which is what this capsule is called, and we had you look at these cells right here because these cells are simple squamous that line this capsule. You might figure they would be simple squamous because all they're going to do is act to allow fluids to flow through them to get out, to get into the capsule here. Okay? Got that, Elizabeth?
I do. You should probably upload your new version of your slide PowerPoint to D2L.
Why?
Because we don't have that one.
You don't have that slide?
No.
Gosh.
And like 5 other slides that you mentioned.
Sorry.
Just throw it out there.
I have no idea where the next copy is. I've got so many copies of all these lectures, it drives me crazy. All right, so anyway, here's the glomerulus, talking about it. It's basically about 50 intertwining capillaries. Blood goes in through an afferent arteriole, blood leaves through an efferent arteriole, and once it leaves the efferent arteriole, once it comes out up there at the top, it then enters into these peritubular capillaries. And the reason it does that is, well, I'm going to say that right now. Let's keep going. So the only place in your kidney where filtration occurs is here in the glomerulus, in the renal corpuscle. This is the only place that filtration happens. Blood comes in, pressure filters a bunch of stuff out, and that becomes the filtrate that then we're going to work on and perfect until it's perfectly crystal golden urine, right? And just to digress for a second, one time when I was a surgical resident, I was running a 10-mile race, and I had a heat stroke. It was in the spring in Washington, D.C., and my temperature was 108, and they took me to the emergency room, and I was in coma. They told my family to go home. They said, he's not going to make it. He's going to die. And I didn't know anything about it. 12 hours later, it was about midnight, and I woke up, and I found myself laying in the intensive care unit at George Washington University in downtown Washington, D.C., which happened to be the same ICU where Ronald Reagan was taken when he was shot. Anyway, so I'm laying there, and there's 2 nurses over at the desk. There's maybe 4 beds in the whole place. And I've got little curtains on either side of me, and I see these nurses sitting over there, and the lights are down except for a little light they have on their desk. And I said, hey, what's going on? Where am I? They said, hey, he woke up! And because they weren't expecting me to wake up. So anyway, I said, what's going on? They said, well, you had a heat stroke today, and your temperature was 108, and your liver functions and your kidney functions are all completely abnormal. And, it's a bad deal, but it's good that you're awake. That's a great thing. I said, well, call the doctors and tell them. I'm sure they'll be glad to be woken up at midnight. But as I lay there, I thought to myself, heat stroke. I was a second-year surgery resident. I thought I was pretty smart. And I think I'd read a few things about heat stroke, but I wasn't all that bright about it. But I did remember this, and that was that you needed to make urine. And if you weren't making urine, your kidneys were probably shutting down. And if your kidneys were going to shut down, you were probably going to die. because everything else was going to shut down too. So luckily, I had a CVP line in my subclavian on both sides. I had a bunch of temperature gauges up my nose and up my butt. I had a Foley catheter in my bladder. I had an arterial line and I could see my pulse rate up there on the wall from my A line. And I looked down there and I could see that I didn't have any urine in my Foley tube. And I thought, that is not a good sign. So I'm laying there and the nurses are over there minding their business, and I'm looking up and I see there's a big IV bag here and there's a big IV bag there. And I put my hands up there and I undid the little roller clamp on both sides and they just went. And I gave myself 2 liters of Ringer's lactate, IV fluid, salt water. And after I'd gotten in about 1.5 liters or so, I looked down, and sure enough, there was urine in my tube, and it was coming across my leg. And I saw that golden stuff, and I thought, I'm going to be okay. I'm making urine. I'm making pee. I've got kidney function. Because I'd had lots of patients in the ICU by that time, and I knew if they were making urine, they were going to be okay. That's usually was the case. And I'll never forget that. And so I sat there with those IVs running, and then it just started coming. And first it was dark, then it got lighter, and then it got clear. Then I reached up and turned the IVs down, and then, 30 minutes later, the nurses came on and said, "What happened here? Oh, that IV fluid wasn't supposed to run in so fast." I don't know. I had no idea. Write up an incident report, But the point being, and it's just simply that if you give yourself enough fluid, if you have enough IV fluid and blood inside of you, and you've got enough pumping to your kidneys are going to make urine. And if your kidneys are making urine, that tells you, as I said a little while ago, you've got enough blood pressure, you've got enough blood, your heart's working okay, your lungs are working okay, pretty much everything's working okay if you've got urine output. So now after we've made this filtrate here, and the blood and the filtrate has started down this little tube here, it is now in the renal tubule. This is the renal tubule right here. And that renal tubule is going to then do a bunch of different things. There's going to be a part of it called the proximal convoluted tubule. There's going to be the descending loop of Henle, the ascending loop of Henle. There's going to be a distal convoluted tubule, and so forth. So, and all of these different parts of that renal tubule are going to be trying to do something else with that filtrate. They're either going to be trying to put stuff in to get rid of it, make it urine, or they're going to be trying to pull stuff out, okay? Pump stuff out of the renal tubules in order to save, to keep inside of you, okay? Does that make some sense? So what's going to happen is from the time the fluid leaves right here and starts down the renal tubule, we're going to reabsorb a lot of useful organic nutrients that were pushed out, like sugar. The sugar just got pushed out with the spaghetti, right, with the water from the spaghetti, and became part of the filtrate that's in that tubule. Then we're going to also reabsorb more than 90% of all that water. So even though we poured it out and it went through the colander and it came out of these arteries and it came into here, we're going to eventually reabsorb 90% of that. And if you think about that, that means that we formed 10 times more fluid into the renal, 10 times more fluid down here than we actually are going to pee out. Okay? We're going to reabsorb 90% of it as it goes down the way. Make sense? And then the final stage, the third one, is the secretion. We're going to secrete waste products that we didn't get rid of just by filtration. We're going to actively pump them into the urine to get rid of them as well. Okay. In the cortex, now, remember looking at our picture of the kidney from a few minutes ago. Here's the kidney. And here's the dividing line between the cortex out here and the medulla down here. Okay? Most all of these glomeruli are located out here in the cortex, like I showed you on that. Looks like Brussels sprouts, kind of, doesn't it? You know how Brussels sprouts grow, Miss Taylor? They grow on trees. They grow on bushes. How do Brussels sprouts grow? Anybody know this?
Tree.
We grow on central stalks.
Stalks.
Yeah. They grow on stalks. And the only reason I know this is because I was in Fred Meyer's about a month ago, and they were selling stalks of Brussels sprouts. And it's a stalk about this big around, and it's got little Brussels sprouts on all sides, and maybe they're in a piece this long. There's maybe 20 of the little sprouts. Why did he say that? It sounds so stupid, Sessions. I wanted to go back and show you that other picture. I guess I can't find it now, probably. Yeah, right here. This looks like a stalk of Brussels sprouts right here, doesn't it? With a bunch of little glomeruli on either side. Come on, help me out, guys. Help me out. Okay. Anyway. This is an important point right here, is that this filtration, remember, it was just a pressure thing, and the fluid that comes out of there does not have proteins in it. The reason it doesn't have proteins in it is because the proteins are very big, and they won't fit through the little holes in the walls of the arteries that let it out. They don't fit through the colander. Okay? So pretty much you could say that filtrate is like blood plasma. In other words, it doesn't have red cells in it, and it doesn't have any of those proteins in it, which means it also doesn't have any of the lipoproteins in it, the good cholesterol and the bad cholesterol and that stuff, so forth. So it's pretty much like plasma. All right, I've said that already. I'm going to skip collecting ducts. Let's talk about these guys here. We have two basic types of nephrons. One is called cortical nephrons, which are like these guys right here. And the difference between cortical nephrons and juxtamedullary nephrons is that the descending loop of Henle here, the descending thing, is much longer in these juxtamedullary nephrons. Now, what does that mean, juxtamedullary? Well, it means they're pretty close to the medulla. Okay, they're juxtamedullary. And so the glomerulus here is close to the line between cortex above, medulla below, but they go way down in here. And these are the ones we're mostly going to talk about as we go through this, because it's these long ones like this is what allows us to concentrate our urine and make really thick urine, which means we don't have to make a lot of urine, which means we can save water, which is really good if you live in a hot climate, or if you're a squirrel. All right, this is a bigger picture of what I drew over here, but here's the glomerulus right here. Here's the afferent and efferent arteries, the afferent coming in, the efferent coming out, a glom of blood vessels right in there, and here's the capsule going around it. So any fluid that gets pushed out through the walls of the aorta the walls of the artery become filtrate, and then they start down through these renal tubules. The first area is called the proximal convoluted tubule, first area. Then it enters into the descending limb of the loop of Henle. Descending loop goes way down here, and then it comes into the ascending limb, which goes way back up. And when he gets up to the top here, it enters into what this thing here is called the distal convoluted tubule. And these little boxes tell you kind of what happens in each of those. After it's gone down and back, it heads into the collecting tubules, the collecting duct rather. The collecting duct, all it does is reabsorb water. So we reabsorb the water, and then what's left down here, when it gets to this point, what's called the papillary duct, which is on the tip of those little papillae, is actually called urine. Okay, that's the first time that we call it urine. Up until that, we just called it filtrate. About 85% of our nephrons are what we call cortical nephrons, which means they're kind of up in the cortex. They have a very short loop of Henle. In other words, it's up here, it comes down a little bit and goes back up. It may not even get out of the cortex. It stays up high. And then the other ones, the 15%, which, like I said, are the ones we're going to study most about, are called juxtamedullary. So they live right down here on the dividing line between cortex and medulla. And even though they're close to the margin here, they go way down here. They're really long loops of Henle. In fact, we call them vasa recta, or the tubule, the capillaries that run along with them. Vasa meaning blood vessel, recta meaning straight, right? Rectum, straight. Rectus abdominis, straight. Okay. I think I'm going to stop right here. And because I have some videos that I want to show you that are real short that I think do a good job of explaining how things move in and out of the renal tubule as it passes through the different parts. I think you would be very well served if you could read a good bit of this chapter by the time we meet next time. Okay? Have a great weekend. Have a great Super Bowl. I'm going to Seattle for the weekend. Huh? Yeah. I like Seattle a lot. It's just rough. Yeah.
Maybe that's why
Well, have you seen how many developments are going on?
Oh, it's unbelievable. I tell you, when I leave here, I go that way down Springville, and then I go down Kaiser or something, Free Spectrum, and then I go that way down. When you get to Cornell, I go that way, and then I usually take a left, a right, and go out on 26, just before I get into 217. It really is. But you know what? It was country. 2 years ago, you went down there, it was country. Now you look at it, I know there's more than 1,000 new housing units. Apartments, condos, houses that are 5 feet apart down there. And there's stores, and there's theaters, and there's everything. Yeah. It's like, oh, I know. It's to the point right now where you've almost got to live out in North Plains to get a reasonable price.
It's not to see people selling more and more land. You know, they go to development.
Huh? Oh, I know. That's what we were just saying. Worse in the whole country. But it seems to me like it's getting worse here.
I agree.